My name is Jireh Arputhamoni. I am working as an assistant professor AC in PSN College of Engineering and Technology. I am going to present a seminar in 8051 and its application. 8051 acts as an embedded system. So we are going to see about the introduction. What is new microprocessor? Microprocessor means nothing but it's an electronic device. We can compute arithmetic logical units and performing so many operations. What is the difference between microcontroller and microprocessor? Nothing but the microprocessor having external connection of memory, but in microcontroller it having embedded, that is nothing but a RAM or ROM or interconnector with the microprocessor is called microcontroller, because the microcontroller having inbuilt memory, but in microprocessor there is no inbuilt memory, it has only external memory. So we are going to discuss about microcontroller, that is 8051 microcontroller. 8051 microcontroller having 8-bit data bus and 16-bit address bus. So in the block diagram, 8051 block diagram, there is oscillator, CPU, interrupt controller, bus controller, 4 I/O ports, serial port, 2 timers, RAM and ROM. So the microcontroller having inbuilt RAM and ROM memory. Here, the main difference between microprocessor and microcontroller, the microcontroller having some external features. One is timer 0 and timer 1. Next one is serial port. Serial port also having inbuilt within microcontroller. In the microprocessor it is an external interface, but in microcontroller it is an internal interface, that is serial port. So serial port TXD is the transmitter and RDX is receiver. So these two are the communication purpose of serial communication. In the serial communication, parallel data, 8-bit data is transferred to serial data and it is transmitter, and at the receiver it is received. 4 I/O ports. So in 4 I/O ports, P1, P0, P2, P3 are the 4 ports act as a I/O port. Another one is RAM. RAM is a random access memory. RAM is random access memory. So it read and write to the memory, that is called random access memory. Next one is ROM memory. ROM memory is read-only memory. We can only read the data in the memory. Next one is external interrupt. First we are going to discuss about the interrupt controller. What is meant by interrupt? That is, interrupt means nothing but when the main program of microcontroller is executed, when we are given an interrupt, external interrupt from the valve, it goes and execute the external interrupt, and afterwards it returns to the main program. This is called interrupt. So the external interrupt means externally that is given from outside the valve, that is called external interrupt. Next one is oscillator. Oscillator means nothing but here the crystal oscillator is employed in microcontroller 8051. So the crystal oscillator having a 2 capacitor and it is connected with crystal of oscillation. It determines the corresponding frequency of the microcontroller. So we can determine the frequency of microcontroller with the oscillator only. So next one is timer 1 and timer 0. These two are timer and the counter. A timer means nothing but, so for example, in the washing machine we are setting 45 as the maximum time. It decrements 1 by 1. Afterwards it goes to 0. After 0, so it comes out of the loop. So that is called timer. After 45 minutes decrementing to 0, it come out of the loop and the washing machine is stopped. Next one is the architecture. This is an architecture of 8051. So here, so the important things are temporary register 2, temporary register TP1 and TP2 are 2 temporary register, and ALU. ALU is arithmetic logical unit. So arithmetic logical units means nothing but it performs addition, subtraction, multiplication, divisions, etc. So here another one is accumulator. Accumulator is a register that stores the arithmetic logical results. Next one is RAM, ROM. So next one is port 0 latch, port 2 latch. So these are the port 0, port 1, port 2, port 3. There are 4 ports in the 8051 microcontroller. So port 0, port 2, port 1 are IO port, but in the third port is a special port because it having some specialities, interrupts, timer, counter, these are enabled. Next one is PSW. PSW means nothing but program status flag. So next one is here the oscillator. We already discussed about oscillator. Oscillator XTAL1 and XTAL2. So these two are the crystals. It produces an oscillation. Next one is DPTR. DPTR nothing but data pointer. PC, program counter, nothing but, what's the program counter means? Nothing but the program counter is next instruction to be executed is pointed by PC. Next one is PC increment. So to increment the PC, next one is buffer. Next, there are some special function registers are there. We can discuss afterwards. The special function registers are PCON, CCON, TMOD, TCON. So these are the special function registers. So next one is the pin diagram. Pin diagram of 8051. So in 8051, the first 8 pins represent first port, that is IO port. It will act as IO port. The 9th pin is RST, that is reset. Next one is 10 to 17 is the third port 3. That is nothing but RxD. RxD is receiver, transmitter. In a serial communication, we are transmit the data and receive the data. That is for 10th and 11th pin. Next one is INTO and INT1. That is interrupt pins. These two are interrupt pins. Next one is T0 and T1 are the timer 0 and timer 1. It is connected with the that port 3. So next one is read write. So when we read and write to the interface, that is called read and write. That is 16th pin and 17th pin. So 18th pin and 19th pin are STAL2 and STAL1. So these two are oscillator. Oscillator which generates the constant frequency. VSS is the supply. Another one is 21 pin to 28 pin, that is port 2. So port 2 having higher order address bus, that is A8 to A15, that is higher order address bus. Next one is 29 is PSEN. Next one is 30th bit. 30th bit is ALE. ALE means address latch enable. Next one is enabling bit. EA. 31 bit is enabling bit, enabling the chip. So in the modern trend, we are having the microcontroller as a chip. That's the modern microcontrollers. So here 32 to 39 is port 0. So port 0 are address data latch of 0 to 7. Address data latch 0 to 7, that is port 0. Next one is 40th pin, that is VCC. VCC is supply for the chip to work. Next one is memory. So there are two memories are there. I already discussed the memory, that is program memory. Program memory is read-only memory. Data memory is read and write access memory. So these are the two types of memories in microcontroller. One is program memory, that is only readable memory. Another one is data memory, is read and write memory. Okay, so this is the corresponding figures that assess that PSNE. PSNE is enabling the bit, enabling an external bit or disabling the external bit. So next one is the data wide is 8 bit. Registers also wide in 8 bit. The address also in 8 bit. 8 bit for only 256 bit. PC is the 16 bit, nothing but up to 64 program memory. DPTR is 16 bit for external data up to 64 memory. So here we are discussing about memory. So we already know that two types of memory are there: program memory and data memory. The program memory only read-only memory. Data memory, it can read and write memory. So next one is accessing external memory. When we are accessing an external memory to the microcontroller, that is 8051. So this is the block diagram. This is the 8051 block diagram. That is ALE, port 0 or port 2. So these are the address and data bus. So next one is we are latching with the EEPROM. EEPROM is a programmable memory executing from external program memory. So in the next diagram, it is external data memory. We already know that in the external data memory, we are connecting microcontroller with an external data memory. So data memory access the read and write. It can read and write also. So this is an external memory. External memory accessed by an 8051 microcontroller. So here write and read are accessed. And another one is the latch is given with the port 0. Port 0 is given to the data memory and latch, address latch. Program memory and data memory are separate, can be an external or internal. 20 internal flash for all-mode control. So in a special microcontroller, Arduino microcontroller, it having a flash memory because we can compute the programs, compile the program continuously, because when we compile the program, it is automatically erased, and after we can upload another program and we can run the same program, another program in the same flash memory. So this is one flash memory is having a special character, read only. So next one is read only. Next one is internal data memory. Internal data memory. Data memory contains all the process state, lower 128 byte register general data, upper having 128 byte. Indirectly address 128 byte used for stack. Direct addressing, a special function. So here the internal data memories are one is data memory, internal data memory, another one is lower 128 byte internal RAM. In the internal RAM, we can add the special function registers are there. So next one is port. There are 4 ports: port 0, port 1, port 2, port 3. So port 0 is external memory accessing a lower order byte. Next one is port 2, external memory accessing higher address byte. Port 0 is general purpose IO. General purpose IO. Port 0 is for timer and counter 2. Next one is port 3, that is special function. That is RxD is a serial one, TXD is a serial output, INTO is external interrupt, INT0 is external interrupt, TO is timer counter external input, T1 is timer counter 1 external input. Read and write. External data memory reads the stub and write is nothing but external memory, data memory is write stub. So these are the ports: port 0, port 1, port 2, port 3. So these are actuator, but the special function is port 3. Next one is program status var. Program status var, register set selector select status data. So first one is the fourth, that is PSW7 is carry flag receive. When there is on carry, the flag is set. The 7th pin is set. So 6th pin is auxiliary carry is received. When the auxiliary carry is received, it is set, otherwise reset. Next one is PSW5, nothing but general purpose status flag. It gives the status flag. Next one is RS1. RS1 is PSW4, bag register select bit. Bag register select bit. So next one is RSO. RSO is PSW3. So PSW3 and the PSW4 are the bit. It determines the corresponding register bag. When these two are 0, port 0 is selected. When 01, port, that is register bag 1 is selected. When 10, these two pins are 10, so the port 2 is selected. 11, the port 3 is selected. Next one is OV. OV for PSW2. So PSW2 means nothing but overflowing flag set by arithmetic operation. When there is any overflowing is take place in arithmetic operation, the overflow flag is set. PSW1, user definable flag, user definable flag. P is the PSW 0, that is parity of an accumulator set by hardware to 1 if it contains odd number of ones or otherwise reset. So odd number of ones means it's odd parity, otherwise that is even parity. So next one is instruction timing. Instruction timing is nothing but, so we are generating the frequency of oscillation of your microcontroller using crystal oscillator. So that is the first thing. So next one is ALE. ALE enables the operation. ALE enables the operation. So next one is the parallel execution. The parallel execution of things are called pipelining. So in the pipelining, we are executing parallel. First one is read opcode and read next opcode. So these are parallel executor. This is called this is called pipelining. So pipelining increase the speed of CPU. Next one is timer. Basically it having two timers. Timer mode increase every machine cycle. So timer is nothing but, for example, the washing machine. The timer is set to the washing machine, it decreases, afterwards it goes to 0, that is called timer setting. Next one is counter. Counter means nothing but the incoming pulse or counter. When the incoming pulse or counter, for example, in your Arduino microcontroller, we are given a ultrasonic sensor. It produces a pulse. We are counting the pulse means, for example, an application, we are fixing a ultrasonic sensor in a door. When 10 members are crossed, it generates 10 pulses. So that is given to the counter and it counts the 10 members are inside the room. So this is a small example for application using an Arduino microcontroller. The Arduino microcontroller is special microcontroller. It having so many applications over there in modern trend. Assessing timer value directly. Timer can cause an interrupt. So we can cause a timer interrupt. The timer one can be provide programmable baud rate for serial communication. Timer counter operation, mode control register, that is T mode, and other one is control register. So here the timer and counter control register, TCON, that is TCON, TF1. TF1 is nothing but overflowing flag of first timer. Next one is TR1. TR1 is the timer 1 run control bit. Next one is TF0, that is timer 0 overflow. Next one is TR0. TR0 is nothing but timer 0 running control. Next one is IE1, nothing but interrupt edge flag. Next one is IT1, nothing but interrupt one type control bit. Next one is IE0. IE0 is the interrupt 0 edge flag. Next one is IT0, interrupt 0 type control bit. Timer controller mode 0. Mode 1 same as a mode 0, but usually all the 16 bits. Okay, next one is here the top one is timer, next one is counter. So here we are given the interrupt, timer interrupt. These are the timer interrupt, and this one is timer, this one is counter. So when the C bar T inverse is equal to 0, it acts as a counter. Next one is it acts as when one, that is it's called a timer. Next one is these 3 pins are to it generates the interrupt in timer. So the mode 1 is 13 bit counter. This is TL1 and TH1. These are the threshold value. So it gives the timer interrupt for mode 1. So next one is timer counter mode 2. So nothing but it is 8-bit counter automatic reload on overflow. So here also there is, for example, we are setting a timer for corresponding washing machine, that is 45 minutes, means nothing but it go to the 0 and it reloads to 45 and it decreased one by one and it reaches the 0. This is called reload on overflow. This is mode 2. Next one is mode 3. Timer counter mode 3. Apply to counter timer 0. So here also this is the timer, and the top one is that is oscillator with counter. Okay, so this enables the timer T0. It enables the timer interrupt. It controls the corresponding thing, and the TL0 is 8-bit. This is an 8-bit interrupt, 8-bit time counter, 8-bit counter. So next we are going to the application. What are the applications of an microcontroller? Means nothing but the microcontroller acts as a embedded system in so many applications. Here the sensor is first one. Next one is hardware unit, application specified logic, timers, analog to digital conversion, digital to analog conversion. So these are the hardwares used. Next one is memory and processor. So memory and processor, the memory and processor attached, it is called the microcontroller. So microcontroller acts as a embedded system. So here the input is a sensor and the output is a mechanical actuators. So in between there are having hardware units. Another one is the main thing is a microcontroller. The microprocessor and memory is merged to call as a microcontroller. So for example, when we are connecting a sensor and in one end, the left of the thing, it senses the pressure, temperature, humidity, and it processes. And for example, in a car, we are sensing a accelerometer. We are setting an accelerometer. It senses the accelerometer value. There is any collision. It goes to the hardware unit and it switches the actuation. Actuation means nothing but the balloon in the car is expanded, and there is any collision, the accelerometer value is increased. So after accelerometer value is increased, it going to switch on the balloon in the car. So this is an example for an embedded part of an embedded system. Microcontroller acts as a part of embedded system. So next one is part of an embedded system. Actuator. Actuator is a mechanical component. So actuator is a mechanical component. For example, when sensor, that is a frame sensor or a gas sensor is connected in the left hand side, that is connected with hardware, that is another one is microcontroller. So when the gas is sensed, the actuator closes the valve of the gas. So this is a small application of an embedded system using 8051 or Arduino special microcontroller. These are the special microcontroller. Next one is sensing input. Sensing input. Sensor sense the input. So for example, in a car is collided with another car. So the accelerometer indicates that acceleration is high. So it informs to the corresponding police station and another one is hospital, near hospital. So this is a simple project in the microcontroller, using the microcontroller. So next one is data conversion, data storage, data processing. So these two are the next blocks. Data conversion. What are the data conversion means? Nothing but the sensor output is analog one. So we are converting analog data into digital data to process the value in the microcontroller, because the microcontroller only understand the digital values. So the analog data are converted into digital data that is stored and processed. So the decision making. So decision making depend upon the collision rate. We can take the decision making, because in a camera, so depend upon the nature we can make the decision, because the climate is very cool, means we can introduce the light, because the darkness is, we can avoid the darkness. So therefore for designing a camera, so there are some criteria there, because the light is low means we have to produce a light and take the photo. So that are the depend upon the climate and light conditions. Range of implementation, single chip implementation, system on chip. Next one is function and designing criteria, monitoring and control function for the overall system. Monitoring and control function for overall system. Vehicle control. So in an automatic vehicle, someone has introduced as artificial intelligence for automatic vehicle control. So for automatic vehicle control, monitoring and controlling functions for the overall system. So here monitoring and its control the function of vehicle control. So to the vehicle is moving right side or left side. So that is controlled by monitoring and control function in an automatic vehicle. Function processing function, telecommunication system, data compression, routing example, information function, information process function. So in the telecommunication, the data compression. So when we transmit that data, we are compressing and afterwards we are transmitting, and receiving and encrypt the same thing. Routing also there. Next one is criteria, performance, reliability, ability, safety, usability, etc. Some common instructions, common characteristics, single function, execute a single program repeatedly. So there are so many ways of embedded system. One is single function. One is single function means a specific task only performed. A single program is executed repeatedly. that is called single functional. Time constraint. Time constraint is low cost. Time constraint is low cost, low power, small, fast, etc. So microcontroller having a small expansion, another one is small power. So depend upon this one, the criteria is given. Next one is reactive and real time. Continuously reacts to change in the system environment. So this is one is, so depend upon the climate, depend upon the light coverage, we can give a reactive. For example, a camera. For designing a camera, so we have to observe the light. What about the light performance? The light is very high, means we have to reduce the flash. So this is one reactive. Another one is there is no light, we have to produce the flashlight. So these are the some reactives. So another one is real time. So depend up. Next one is must computing certain results in real time without delay. So another one is there is no delay. There is delay means there is delay. Delay means there is some problem. So we have to avoid the delay and we have to produce real time application for the recent application. So next one is embedded system. For example, digital camera. In a digital camera, there is one lens. Next one is CCD. Next one is analog to digital converter. So the analog value is converted to digital. That is given to CCD preprocess. That is given to pixels coprocessor. So pixels coprocessor, it process. Next one is JPEG code. Next one is given from pixels coprocessor to microcontroller. So next one is microcontroller to internal bus. So internal bus, there is one memory controller DMA. DMA means nothing but direct memory access. So it directly access the memory without the interference of microcontroller. ISA bus interface UART nothing but universal asynchronous transmit and receiver. Next one is display control. Next one is LCD control. So last one is digital to analog conversion. So digital to analog conversion, it converts digital data to analog data. Next one is designing challenge optimization. Observing design goal, constraint and implementation with designer functionality. Key design challenge. Stimulation, optimization, neural design matrix, designing matrix. A measurable features of system implementation, optimization design matrix is a key challenge. So nothing but that matrix means, design matrix means nothing but it's a performance evolution of a system. So here the performance evolution of system, how much time it takes to complete an event. So another one is physical size, the physical space required by the system. Performance, the execution or throughout of the system. So when we click the camera, how much time it processes and give the output, that is the measurement. That's the measurement of performance in the digital camera. So next one is power, the amount of power consumed by the system. So when we charge the camera, digital camera, it works up to how many hours. There's also another one is the power consumed by this camera, flexibility, the ability to change the functionality of a system. Next one is cost. So it depends upon the cost. The common matrix, it depends upon the cost also. How many dollars to design a digital camera? That is the main concept. Next one is designing matrix competition, especially with the software and hardware is needed to optimize design matrix. Not just hardware or software expert as is common. A design must be compatible with various technology. So there are matrix, performance matrix, power, size, NRE cost. So these are the things. Another one is software used in microcontroller. So another one is hardware, CCD preprocessor. Next one is JPEG coder, pixels coprocessor. So these are the hardwares used in the digital cameras. Time required to develop a product to point it can be sold to customer. So next one is timer to market. So when we produce that, how many days to produce a digital camera and give it to the market. So that is the thing. That is nothing. The next one is market window, period during which the product will highest sales. Average time to market constraint is above 8 months. Delay can be costly. So depend upon the time to market. Next one is the performance design matrix, widely measured of the system, widely observed clock frequency, instruction per second, not good measurement. Digital camera, a user care about many fast it process image. So here the digital camera, its performance is evaluated by fast its processing image. So how it is fast to process the image, that is called the performance evolution. The latency, the time between task end and start. For example, camera 1 and camera 2 image is 0.25 second throughout task per second. Camera A is 8 image per second throughout can be more than latency to implement due to concurrence. Example, camera B may process 8 images per second. By capturing a new image, previously image is being stored. So speed up B over a B performance divided by A performance, that is 8 divided by 4, that is 2 throughput speed up. Next one is 3 key technology. The manner of accumulation of task, especially using technical process method knowledge. Three key technology for embedded system. One is processor technology, IC technology. Another one is designing technology. One is processor technology. The architecture of completion engine used to implement a designer functionality. Processor does not have been programmed. In the digital camera, processor cannot be designed program. So here one is general purpose, another one is application specified, another one is hardware. So there are three types. One is a control logic and state register. Another one is program memory, assembling code. So next one is data part. So this one is register file, general ALU and data memory. So another one is application. So application specified means nothing but it specifies an application. A specified application. Next one is single purpose. Single purpose is an hardware. So here there is no execution of programmable devices. So this is called hardware, single hardware. So next one is processor technology. Processor varying in their customer for the problem at hand. One is general purpose processor, another one is application specified processor, another one is single specified processor. So beside the functionality, so this is having a loop, that is total is equal to 0, for I is equal to 1 to n loop, total plus m of I end the loop. So depend upon the loop it is executed. So next one is general purpose processor, programmable device used in a various of application, also known as microprocessor. So features, what are the features of general purpose processor? Program memory. Next one is general data path with a large register file and general ALU. So these are the program memory. Next one is features of program memory. User benefit, low time to market and NRE cost, high flexibility. So these are the general purpose processor advantages. Next one is Intel AMD, the most well known, but there are hundred of others. Next one is application specific processor. Programmable processor optimized for a particular class of application having common characteristics compared with general purpose and single purpose. So optimized for a particular class of application commonly characteristics. Next one is feature, programmable memory. Next one is optimized data, special function unit, benefit, some flexibility and good performance, size and power. So these are the features of application specified process. So application specific process means it executes a single program, that is called application specified process. So depend upon the application we can program the process. Next one is independent of processor technology, basic trend of general versus customer. With respect to processor technology or IC technology, the two technologies are independent. So this one is general purpose processor. Another one is ASIP. Next one is single purpose processor. So second one is application specified processor. So here one is PLD. One is PLD. Another one is semi-custom customer, full customer. So these are the categories of independent of processor technology. So here the customized providing improved, that is power, efficiency, performance, size, cost. So in general providing improved flexibility, maintainability, NRE cost, time to prototype, time to market cost is low volume. So these are the features of the embedded system. Next one is co-design methodology. Designing of system involves both hardware and software components. Starts with formal abstraction specification, series of refined map to target architecture, location, partition, scheduling, communication, synchronize, means to manage large scale and complex system. So these are the co-design. Co-design is nothing but we have to design we are going to design a system, means nothing but we have to design software and hardware to combine together, that is called co-design. So starting off specification, abstract specification, serial refining of target architecture to allocation, portion, scheduling, communication systems. Next one is complex systems. SOC is nothing but system on chip. Millions of gate on a chip. Decreasing process technology, that is deep sub-micro, 0.25 micro and below, decreasing the geometrical size. So it decreases the geometrical size of the corresponding gate. So in a chip, the million of gates are produced. So the density, increase the density, chip density. So the problem, the electronic device automation tool. Another one is time to market. These two are a main problem in a digital camera.